Okay, so now we're going to talk about dividing radicals. So we said on this last sheet right here, we said you can multiply or divide any radicals. They don't have to be like radicals. You can divide any two radicals you want. So for example, if I had the square root of 6 over the square root of 3, because they're both in the house, or square root for lack of a better word, you can just reduce them like you normally would. So what's 6 over 3 normally? 2, but you got to keep it in the square root. Perfect. So your answer here is just the square root of 2. What would this one be? What if I gave you the square root of, I don't know, 4 over the square root of 12? Yes, you're going to get, you can reduce the 4 and the 12. 4 goes into 4 once, 4 goes into 12 3 times. So look at what you have in the numerator. You still have the square root of 1. But what is the square root of 1? 1. Downstairs, what do you have? Square root of 3. Now, here's where we encounter a problem. We are not allowed to leave square roots in the denominator. We have to do a process called rationalizing the denominator in order to undo that. Good guess, and you're very close. So, rationalize the denominator. By the way, denominator. No, I wish you could. You can't just take a number and square it and have it be equal to itself. If I could do that, I would go to my bank every day and say, square my bank account. You know what I mean? They can't. Well, but you're not going to get anywhere. I mean, I did make an equation here, but it's actually not going to help you. Because I'm just taking this. Imagine you didn't have this. If I just started you with this and I said rationalize this denominator, there is no other side here. Right? It's not like I can, you're right though. If you had an equation, you could square both sides, but I don't have an other side. Yep.
Don't you like multiply the top and the bottom both by square root of 3?
By square root of 3, exactly. So here's what I need to do. I'm going to multiply the top and the bottom by the square root of 3 over the square root of 3. Now, what is this really? What's the square root of 3? It's really 1. You're allowed to multiply any number you want by 1, and you haven't changed its value. If I go into my bank account, or to my, my bank person, and I say multiply my bank account by 1, they're like, okay, just did it. Right? Because they haven't changed the value. So they have no problem doing it. But by multiplying by this, watch what's going to happen to our square roots in the denominator. Across the top, what is 1 times the square root of 3?
1 square root of 3.
Yeah, do you need the 1 in front?
Nope.
You don't need it. You can write it if you want. You don't have to. Now, look down here, though. What's the square root of 3 times the square root of 3?
3.
Just 3. Right? When it's the same thing, it basically just cancels itself out. Another way to think about it is square root of 3 times square root of 3 is square root of 9. But you know the square root of 9 is just 3. So anyway, by doing this little process, I ended up with no square roots in the denominator. That's what we call rationalizing the denominator. You're allowed to have square roots in the numerator, that's fine, but you can't leave them in the denominator. Does that make sense? So, let's try another one. Say I had, I don't know, 4 over the square root of 7. What am I going to multiply by?
Square root of 7.
Square root of 7 over square root of 7. And my new numerator would be 4 root 7. And what's in the denominator? 7. Perfect. Now, here's a good question. Can I cancel these two 7s? No, because one's in the radical and one's not. They would either both have to be in or both have to be out. You can't pick and choose, right? One's in, one's out. You can't touch them. Now, these two are both out. So if these two had something I could reduce by, I would do that. But in this case, they don't. I can't reduce a 4 and a 7. So I'm finished. Is that all right? So let's say, I don't know, pretend my answer had been this. 10 root 3 over 6. Could I reduce an answer like that? Yes, these two that are both outside of the radical, they have a common factor, which is 2. 2 goes into 10 5 times, 2 goes into 6 3 times. Can I cancel these two? No, because he's not in a radical. So your final answer here would just be 5 root 3 over 3. Okay, you just got to get in that mindset that you can only cancel if they're both in or both out. If you have 1 and 1, you really can't touch them, leave them alone. All right? Now, things do get a little bit trickier when you have a binomial in your denominator. So, check out a problem like this. Say I had 6 over 2, I don't know, plus the square root of 3. Now, our ultimate goal is to get rid of the square root in the denominator. I don't want you to write this down because this is going to be wrong. Say you tried the same thing that we tried above, and you're like, oh, let's just multiply by the square root of 3 over square root of 3. Watch, it's not going to work. Don't write this on your paper, though, but I'll show you why.
Can't you divide first?
No, because I would have to be able to divide into everybody, and I can't. So across the top, I'd get 6 root 3, but then in the denominator, I have to distribute that root 3 to both of these things, because it's a binomial, right? So I'd get root 3 times 2. That's 2 root 3. And then what's root 3 times root 3?
1.
Not 1.
3, right?
3, yep, plus 3. Well, guys, did you get rid of the square root in the denominator? No, you just moved it over. You didn't help yourself any. So that's not what we do in this case. You're not going to get anywhere. You're going to waste your time. So what do we do?
Do you multiply that by 2 plus that?
Oh, you're so close. You're so close.
Minus that?
Yes! You're actually going to multiply by the conjugate. Remember in the last chapter, if that was a 0, wasn't 2 minus root 3 automatically a 0? Remember we're talking about those conjugate pairs?
Yeah.
Good. The same thing applies here. You don't want to multiply by the exact same thing that you see. You want the conjugate. So I want this to be 2 minus root 3 on top and on bottom. This you should write down because watch how cool this turns out. If you multiply across the top, now be careful, this is a binomial. So anytime I have binomials, I like to put parentheses around them just to remind myself. Okay? If you multiply that top, what do you actually get out?
6 minus.
12, 6 root 3, right? Yeah, because when you multiply the 6 times the root 3, you just write them next to each other. Okay, now watch downstairs. I have a binomial times a binomial, so I'm actually going to FOIL this, right? So let's FOIL this together. First, 4, right? Outsides, you're going to get a minus 2 root 3. Insides, what do you get?
Positive 2.
Plus 2 root 3. Oh, cool. Now look at these last. Plus root 3 times minus root 3 is really,
0.
no, what's
Negative root 3? Or
negative 3? Because the square roots cancel out. When you have, yes, you just get what's underneath.
0, I said.
Yes, good. Now, take a look. These two cancel each other out. Minus 2 root 3 plus 2 root 3. That should happen every single time. If you did this right, the square roots are automatically going to cancel out. Now, all I have left is 4 minus 3, so my denominator is really just, if I have 4 minus 3, I really get
1.
1. So I don't even need to write the denominator. So I have 12 minus 6 root 3. Guys, can I subtract those two? Can I actually do 12 minus 6 root 3?
No.
No, because they are not like radicals. If you were going to subtract these two, he would have to have a root 3 on them also. You can do 12 root 3 minus 6 root 3, but if one has one and one doesn't, you can't touch it. That's as far as you can go. So that would be your answer there. Okay? So that's how you handle dividing and having a square root in the denominator.